Okay, Assalamualaikum. So this video still about 2.2. So I will discuss second exercise, which is number 3 from exercise 2.1. Okay. Okay. So as just now, first step is to extract information. A study on the number of drill, can be made by micro drill machine is conducted. A random sample of 50 micro drill machines was drawn and the data is given as follows. So we have 15 sample of micro drill machine, and the data here is about number of drill that can be made. So find I modified this question. It is about one-sided confidence interval. So find a one-sided upper bound of a 95% confidence interval for the mean number of drill that can be made by micro drill machine. So give comment on the parameter estimate. So the variable here, so it is clear that it is about confidence interval of the mean. So we are looking for the confidence interval to estimate the mean. The mu here. So the variable you can identify from the question here. So it is a mean number of drill. So this is your variable, number of drill. So there is no unit lah. It's a number of drill. So random, the first information here, a random sample of 15 micro drill machine. So n equal to 15. So the data here is a sample data. So automatically any value that you calculate from this data will produce statistic value or sample value. If you calculate mean, then you will get x bar. If you calculate standard deviation or variance, you will get s square or s. Not the sigma, because the data here from sample 15. So you can find your s bar information that we need for the CI of mu and also the s. So key in this data in your calculator. You already discussed in chapter 1, and then get your s bar and s. So you should get x bar 12 and s is a 2.3299. And then we have again 95%. So alpha is 5%. So that's it, the information that we have. Then we go to the solution. So we need one-sided upper bound. So we need to choose which formula that we need to use. So the first condition, sigma is known or unknown. So based on this information, there is no sigma or sigma square. So automatically sigma is unknown because we have s. So sigma is unknown. And then the second condition here, it is your n. So in this case, we have 15. N equal to 15 means that it is less than 30. So we use formula with the s and t. So let me back to the formula. Unknown and less than 30. So use this formula. We modified the alpha because it is one-sided, and we need the upper bound, so use the B formula for the upper bound. Before that, I forget to mention in the previous video. Should be here or here. Should be here. So one-sided. So the mu here, in general, mu is between infinity, negative infinity to the infinity. Like I mentioned in the video of 2.1. Okay, in general, mu it is between negative infinity to the infinity, but it is depends on the variable. Okay, if the variable cannot be negative value, so your mu start from 0. Okay, because we need to determine what is lower bound value or upper bound value when we calculate for the one-sided. Okay, so we calculate for the b only. Okay, so b only, the value for the b, sigma is unknown and less than 30, then we use formula with the t and s. So s bar plus t only alpha because of one-sided multiply with the s divided by square root n. Okay, so this is formula for the upper bound. So automatically lower bound equal to 0 because of the variable is a number of drills. So there is no negative 1, negative 2 for the number of drill. Okay, so it start from 0. Okay. Sorry, the t and nu lah. Okay, so here nu is a n minus 1, so we have 14. So we have s already, we have n, we have s bar. So we find what is our distribution value. So t alpha 0.05, again no need to divide by 2 because it is one-sided. Nu 14. Okay, so refer to your statistical table. Table 5, page 37. Okay, so if you use the old statistical table, maybe 36 or 38. Okay, so if you refer to your statistical table now, you have column for the nu, and you have the first column, it is a nu. Okay, I will write here. And the first row is a probability value, which is your alpha value. Okay, probability value. So find the combination of 0.05 and 14. Okay, so find 0.05 from the first row and 14 from the first column. So you will have 1.7613. Okay. Okay. So after that, you can substitute in your formula. Okay, I will write here. So 0, okay, x bar is a 12 plus 1.7613. Okay, multiply with the s. Okay. Okay, so you will get 0.30596. Okay, and then because of the variable here, number of drill, it should, so number of drill is a discrete number or whole number. So the answer here, we round up because there is no, it is not continuous value. Number of drill, it is not continuous, it is a discrete number, so we have to round up. So you have 0 and 4 drill. Okay, because it is a number of drill. Okay, so how do we interpret? Similar as before. So we are 95% confident that number confident that mean number of Dre lies between 0 and 4. Okay, or you can talk about the probability. Okay, or the probability of mean number of drill lines between 0 and 4 is 0.95. Also correct. Okay, so I hope that you understand this one. Okay, as I promised, okay, you can redo this exercise, and then if still you don't understand, you can consult your lecturer. Okay, so as I promised, we go back to the example 2.4 here. It is about how to find the n. Okay, so a telephone company wants to estimate, okay, mean number of minutes people in a city spend talking long distance with the 90% confident. Okay, so you have the confidence level here. Automatically you know what is alpha. Okay, so from the past record, okay, an estimate of the standard deviation is a 12 minute. When we say past record, past study, previous study, something that already happened, it is parameter value. Okay, if that value from the past record, past study, already get that value before we start the new research, then it is a parameter value. So the standard deviation here is a sigma. So sigma equal to 12. What is the minimum sample size required so that the estimation error of the mean lies within 5? So this is your E, mean. So it is clear that, okay, minimum sample size. So we are looking for the n. Okay, so so the estimation error given here, it is for the mean. So clear that we have to use the concept of confidence interval for the mean in order to find the n here. Okay, so that's why we use this formula. So we have sigma 12, we have E5. Okay, it doesn't matter, use the plus or the minus one, similar. When we are talking about the error, it could be okay, plus minus 5 could be. So okay, what does it mean here? Okay, so plus minus 5 here, it can be between, okay, let's say that your S bar here. Okay, the error, the value that we tolerate, okay, it is between how to say, okay, let's say this is 12. So plus 5 until 70 minus 5, it is 12 7. Okay, okay, so the value that we tolerate here, it is between 7 to the 70. That's what we meant by estimation error lies within plus minus 5. Okay, okay, so use as it is, you can use the plus or the negative similar. Okay, so from 90% level, you can we can know the alpha from here, then find the distribution value. Okay, so divide by 2, because in your formula we need the alpha over 2, so we have 1.6449. Okay, so you just substitute in this formula. Okay, let's say here you have the as also similar formula. We are using similar formula, but here is a as similar. Okay, so substitute the value here, then you will get this continuous value, the decimal places. Okay, but since we are talking about the n is a discrete number, that's why we round up to the next whole number. Okay, that's why you have 16 here. Okay, so you can try the exercise number 4 here. for the n, because we need the number of tests here is a n. Okay, I think that's it for this video. Okay, see you again. Thank you.